So after nitrogen, we go to the oxides of nitrogen. The first oxide we will talk about is nitrogen 1 oxide. What's the formula of nitrogen 1 oxide? It is N2O. N2O. What's the 2 for? Because the nitrogen 1 oxide, you look, the number in brackets shows the valency. So in this case, nitrogen will have valency 1, oxygen valency 2, that's why N2O. N2O being nitrogen 1 oxide. Let's dive straight into it. How is it prepared? Nitrogen 1 oxide is prepared by thermal decomposition of ammonium nitrate. Now we talked of nitrogen having prepared by thermal decomposition of ammonium nitrite. So from nitrogen to nitrogen 1 oxide, instead of thermal decomposition of ammonium nitrite, you change it to thermal decomposition of ammonium nitrate. You use a similar mixture as the one in nitrogen, thus you change the nitrite with nitrate. So you use a mixture of sodium nitrate plus ammonium chloride, right? Sodium nitrate plus ammonium chloride to prevent an explosion. So sodium nitrate combines with ammonium chloride from ammonium nitrate and sodium chloride. Then the ammonium nitrate decomposes to give nitrogen 1 oxide and water. Mixture of sodium nitrate and ammonium chloride used to prevent an explosion. What are the physical properties of nitrogen 1 oxide? One, it has a pleasant smell. One of the distinguishing factors of N2O is that it has a pleasant smell. It is also colorless, it has no color, insoluble in warm water, soluble in cold water, denser than air, and when we know that if a gas is denser than air, it is collected by downward delivery. Downward delivery also called upward displacement of air. If required dry, pass it through concentrated H2SO4 in a conical flask. Also, nitrogen 1 oxide is the gas that is called laughing gas. As we have heard of laughing gas. What is laughing gas? Laughing gas is this nitrogen 1 oxide. What does laughing gas cause you? It causes you to laugh hysterically when you are recovering from it. Hysterically, like sarcastically. Okay? So this is the setup for the production of N2O. The flask. Now, an important question asked in this area is, why is the flask slanted downwards? The flask is slanted downwards to prevent, as we can see, this mixture of ammonium chloride and sodium nitrate must be heated to thermally decompose ammonium nitrate, right? So when you heat this, there is steam, the condensed steam. So you prevent flowing back of condensed steam. Otherwise, that will crack the flask. So the reason for why is the flask slanted downwards is to prevent flowing back of water or condensed steam, which would otherwise crack the flask. Now, what is the test for the gas? Nitrogen 1 oxide relights a glowing splint and has a pleasant smell. So if you are told to distinguish nitrogen 1 oxide from other gases, what will you say? Nitrogen 1 oxide has a pleasant smell and it relights a glowing splint. Now, why does it relight a glowing splint? As we said, nitrogen does not support combustion, nor does it burn. But N2O does support combustion. The N2O, nitrogen 1 oxide, is an unstable compound. So this compound can be broken down to give nitrogen and oxygen, right? So the oxygen here, when the compound is thermally broken down, does support combustion. So the heat dissociates the nitrogen 1 oxide to oxygen and nitrogen. The oxygen gas relights the glowing splint, hence it supports combustion because it is unstable and it readily decomposes. It is neutral to litmus, it has no effect. Red litmus paper remains red, blue litmus paper remains blue. Now, when N2O is reacted with magnesium, what is the observation? It burns with a bright white flame. Why does it burn? As we say, why does it burn? This is a highly exothermic reaction. It produces a lot of heat. So the heat produced breaks down N2O into nitrogen and oxygen. The oxygen here combines with magnesium to form magnesium oxide, which is a white solid. And the nitrogen that is left is given as a byproduct. Okay? Another reaction, when N2O reacts with copper is brown. But the reaction, also being highly exothermic, breaks down N2O into nitrogen and oxygen. Copper reacts with oxygen, form copper 2 oxide, and nitrogen is given as the byproduct. So the brown solid changes to black. We come to phosphorus. Phosphorus reacts with nitrogen 1 oxide to give phosphorus 5 oxide and nitrogen. White fumes of phosphorus 5 oxide are formed. So any reaction, any metal or any non-metal, when burned with N2O, you should know that N2O does support combustion because it is unstable and the bonds are broken down, and hence oxygen supports combustion. We go to the usage of nitrogen monoxide. Formerly used as an anesthetic in surgeries, as we said, when it was used as an anesthetic in surgeries, the patients recovering from it used to laugh hysterically. That's why we say formerly, not anymore, because now we have new developed forms of anesthesia. It was used as a food additive, and it is an oxidizer in race car engines and rockets. In those engines, the nitrogen 1 oxide, N2O, the oxygen, when N2O is broken down, is used to oxidize the fuels and lead to faster combustion. So that's all we need to know about nitrogen monoxide. So when we say magnesium burns with a bright white flame, I wrote other metals that burn with different flames. So potassium, when it burns in an luminous flame, it burns with a lilac flame. Calcium burns with brick red. Barium burns with apple green, and sodium burns with golden yellow. Now these are not related to our topic here, but it's just a by the way for different areas.